And get. Hello, everyone, and welcome to the Working in Antarctica webinar. It's a VIRTEX series. Today's going to be featuring Dr. James Karner, and he'll be talking about his experiences exploring Antarctica in search of rocks and space. My name is Yolanda Ballard, and I am the program coordinator at the Lunar and Planetary Institute. I work closely with Christine Schupla, who could not be with us here today. She will be back for the additional webinars that are upcoming. I am going to let everyone know that this webinar is going to be recorded. We ask that you keep your microphones on mute. And this video will also be shared out. If you don't want the video to be shared out, well, you can't turn your cameras on. So there's nothing to worry about now. So Dr. James Karner, I'm going to hand him the microphone and let him get started on introducing himself.
Okay, thank you. Thanks for having me. I'm excited to share about my work in Antarctica. I'll start sharing my screen now so you can see my slide presentation. Um, uh, okay, let me just move this box around there. I think I should be okay here. Christine asked me to do this VIRTEX presentation on working in Antarctica. And the kind of work we do in Antarctica as a scientist is I am in charge of a team that goes to Antarctica and hunts for meteorites or rocks from space on the ice and in the moraines around the ice in Antarctica. And here's just a picture of us doing that task of finding meteorites. And you can see, spoiler alert, we're very good at finding meteorites in Antarctica. There's a lot of them. And all those red flags that you see in the background are actually where we found meteorites. And we've marked them with a red flag. Um, Whoops. Okay, so let me see if I can advance there. Okay, so Antarctica is at the bottom of Earth. It is a land mass, but it's covered with ice. This is a satellite image that shows, or a radar image that shows that Antarctica is covered with ice, but it's land under there, under that ice. It's a continent, so there's land under there under all that ice. And if you think about Antarctica as like an overturned bowl, it's very thick in the center by the South Pole. In fact, it's so thick with ice in the South Pole, at the South Pole, it's like 3 miles thick of ice over the continent or the ground. So that's that red dot there. And then there's a couple other places that I've marked here on Antarctica. There's the star, that's McMurdo Station. That's where we start our expeditions. And the green rectangle there or square is where our field area is, where we go and look for meteorites. And kind of from the yellow star and in a curve along to that green square are the Transantarctic Mountains, and that's where the ice is flowing off the Antarctic continent. It butts up against those mountains. It is whittled away, and meteorites come to the surface, and we can find them there. So we want to find blue ice in Antarctica to do our work. But first, how do we get to Antarctica? The journey to the ice. So we usually leave from the western United States, from Los Angeles up here, and it's a long flight on a commercial airplane. It takes about 12 hours to get to New Zealand, and then from New Zealand, we'll take a military flight down to Antarctica. And our first stop on the way to Antarctica is in New Zealand, and that's where the U.S. Antarctic program has its base. And the main place there that they need is the Clothing Distribution Center. And Antarctica is covered with ice. We go there in the summer, so there's 24 hours of sunlight, but it's covered with ice, so it's very cold. Temperatures are right in the range of around 0 degrees Fahrenheit the whole time we're there. So we need lots of warm clothes to work in Antarctica. And here is where we get them at the Clothing Distribution Center in New Zealand. You can see all those things on the wall behind Julie. She was a former ANSMET Antarctic Search for Meteorites team member. That's all the clothes that you get in New Zealand for your trip to Antarctica. And this is the hallmark, the big piece of your clothing that you get for Antarctica. It's called the Big Red Parka. It is a really super warm goose down parka with a nice hood that has some fake fur around the edges to keep your face warm. These are super warm parkas that you wear all the time out in the field in Antarctica. I think if you were to buy one of these from the company that makes them, they'd be several $1,000s. They're really good warm parkas, and that's Big Red. So after we get all our clothes, we pack up our stuff and we board a military aircraft. This is a C-130 or a C-17. They're cargo planes. And we take that military flight all the way down from New Zealand to McMurdo Station in Antarctica. And that's called the ice flight. Now, 10 hours later, after this cramped flight, you're sitting on cargo netting. It's not really a commercial flight, so there's not lot of good airplane seats. There's no movies to watch or anything like that. It's super noisy. You have to wear earplugs. We eventually land in Antarctica, and you can see we landed right on the snow or the ice here. We actually land. They just basically plow a airstrip for these huge planes to land right on the sea ice in Antarctica. So that's what you're seeing here. Nice groomed, smooth, snowy, kind of icy surface there. So 9 hours later, 10 hours later, we're in Antarctica. And this is just a little different satellite version. Now Antarctica's tilted a little, but you can see McMurdo Station. That's where we are now. We arrived there. And then way out among those mountains, you can see the little black specks poking through the ice. Those are mountain tops. And we're going to go way out here to our field area at Davis Nunatax and Mount Ward, which is about 450 miles away from McMurdo Station and only about 200 miles away from the South Pole. So we're way out in the mountains. We're looking for that blue ice to find meteorites. And here's kind of a little cartoon of how we find meteorites in Antarctica or why they're there. Antarctica has been covered with ice for millions of years. And during those millions of years, meteorites have been falling on top of the ice. They've been getting buried with snow, and then they're incorporated into these glaciers. And glaciers are like frozen rivers. They move super slowly, but when they hit the mountains, they hit an obstruction. Their surface is whittled away, ablated away, and the meteorites that are in the glacier kind of are weathered away, and they just stand up on top of the ice in these blue ice areas. So that's how meteorites are concentrated on Antarctica, and that's what we're doing when we're going to Antarctica. We're trying to find these blue ice areas and find the meteorites. That's what a meteorite looks like on blue ice. It's blue ice, by the way, because this is deep ice that has been really compacted. All the air has been squeezed out of it, so it takes on this bluish color. And you can see the ice here is very rough. We call this a scalloped surface. It's just the wind and the sun have made divots in the ice, so it's very rough and very rugged traveling that we do on the ice on our snowmobile or skidoo. This is our home for 6 weeks while we're in the field. You can see we have these are big tents. We sleep two to a tent. So in this season, we have 4 tents that are made two to a tent for people to sleep and live in while we're out there. And then we add 3 extra tents. We have a bathroom tent. We have a science tent where we gather for nightly debriefings, and we can have group meals in there if we want to. And then also this year we had an extra tent. We were very far away from McMurdo Station. This is kind of an empty tent. If we had a snowmobile repair to do, we could bring the snowmobile in there, and it would cut you off from the cold and wind, and we could work on that and repair it there. So this this is our home. We bring all of our food for 5 or 6 weeks into the field. So we're basically self-sufficient once we get way out there into the field. Here's a little close-up of our Scott tents. These are the same tents in this kind of square pyramidal design. This one has a little vestibule. This is the same design that the explorer Scott, Robert Falcon Scott, used in the early 1900s when he went to Antarctica in his quest to get to the South Pole before Amundsen did. So we have the same tent. They're basically an outer shell and an inner shell that keeps air kind of in a layer there. It keeps you warm. We also have, you can see their extra gear here. This is Lauren Edgar standing outside her tent. And each tent has a little solar panel where we can generate a little electricity to charge up our computers and other electronic devices that we'll need for the season. Here's a cooler full of food close to their tent so they can get into that. But we generally store all our food out there, anything that can be frozen, and that's pretty much any type of food except maybe lettuce. We keep that frozen in coolers outside our tents and bring it in when we need to eat. Here's the inside of a tent. You can see it's nice and cozy. We have a lot of pockets to store all kinds of gear and peanut butter. Keep your peanut butter unfrozen up here. These are two of our team members from our last field season. We heat that tent with this little liquid propane burners here, two stoves, and we also do all of our cooking on this stove. You can see some pots and pans and food, things we eat there. This is a satellite phone down here in the right corner, and that's our communication with the outside world. So there's no cell phones in Antarctica, no Wi-Fi, but we do have a satellite phone that we can make calls home with and to McMurdo Station. Okay, so how do we work in Antarctica? And basically, we look for meteorites in two ways. One way is to get on our snowmobiles, which we call skidoos, and we do sweeps of the ice. We're going very slow down the ice in a line, searching for rocks that could be meteorites. And I'll just show you this little video. So we're just slowly going down the ice, searching for rocks that could be meteorites. You can see there's mountains poking through. So there are some terrestrial rocks on the ice, but sometimes we go up to a rock and it might look like a meteorite. And I'll let this run out. If it is a meteorite, you can do a little happy dance. Here's Ralph Harvey, one of our longtime leaders of the program, with a meteorite that he's found on that blue ice. He just hopped off his skidoo and took a better look, and there it was. We also work out on the ice in what we call foot searching, and that's in moraines. So you can see moraines are basically where the glaciers have brought along or brought up a lot of rocks with it. They flow with the ice and they kind of deposit on the sides or in front of the ice. But there's also, along with the thousands and thousands of regular earth rocks in moraines, we found a lot of meteorites in there. So this is the team approaching on foot. There's so many rocks, you can't really drive around on your skidoo in all these rocks, so we have to go on foot and look for those meteorites. And here's what a meteorite in a moraine looks like. This is one of our participants from a past season. You can see all these terrestrial rocks she's kind of lying in, and then a big meteorite with this black fusion crust still on the outside and kind of a rusty interior of that big meteorite she found in a moraine. Now, it's very cold and windy in Antarctica. Like I said, the temperatures are always around 0 degrees Fahrenheit, but the winds can get up to 40, 50 miles an hour and stay that way for days at a time. This is one day we were searching. We went out in the field to search. It was pretty windy and it got windier as we we're looking in this moraine for meteorites, and soon it got too windy. Now, this is the wind. We normally don't work in winds over 20 miles an hour. It's basically a blizzard. But you can see here it was about 25, 30-mile-an-hour winds. And it was basically, this was just before we called off searching for the day because it was just too cold and too windy to search for meteorites. But I'll show you kind of what that looks like. Okay, so that was a cold, windy day in Antarctica where we had to work outside. You really got to be careful to stay warm. We're always checking with everybody out there if they're okay and not getting too cold and drinking enough water and so on. But the truth is that when there's blowing snow and it's super cold like that, we're probably missing a lot of meteorites because we're not concentrating on searching. We're concentrating on staying warm. Um, at the end of the season, our goal for the U.S. Antarctic Search for Meteorites program is to get as many meteorites as possible and recover them and bring them back to the NASA Johnson Space Center and the Smithsonian for them to curate them. And then we loan them out to scientists around the world for scientific study. So at the end of the our little field season, we have to do an inventory. So all these meteorites that we have in the sled here are inventoried. They match our logbook. And then we're going to put all these meteorites into this meteorite cooler, and we're going to get them back to McMurdo Station on the plane, and then eventually get them back frozen on a ship all the way to the Johnson Space Center in Houston, Texas. So here's the final step of our field season. We load all those meteorites into that meteorite cooler, and this meteorite cooler is going to go onto this little airplane we call a Basler, and we're going to take all our stuff and get out of the field, go back to McMurdo Station, and then eventually back to civilization. So I'll end there with one of my favorite pictures of Antarctica. This is a place called La Paz. It's near the South Pole, and there's no mountains, there's no land that peeks through the ice there. The ice is very thick there. So every rock that we found on this ice in this area what had to be a meteorite because there was no terrestrial or earth rock. So we're looking about 200 yards away at this black speck in the center of the screen, and that is a meteorite. So thank you very much. I'll stop my screen sharing and wait for the Q&A.
Thank you so much for that. That was really interesting. I don't think I could hang out in such cold weather. Yeah, hats off to you for that.
We get really good clothing, and you wear several pairs of long underwear and really good hats and mittens. And nowadays, you can even put, we use hand warmers and things like that. And there are some gear that's actually battery powered heaters in it. So
Wow.
yeah, so we try to stay as warm as possible. We get really good gear for it.
Man, well, now is the time where we're going to open up the chat. So for anyone who has, oh, we've got a Q&A. Here we have one already.
Okay.
All right, from Angela O'Neill, what is your favorite rock that you found?
Oh, well, that's a great question. So my favorite meteorite we ever found, I could probably find a picture, but was a piece of it was in a moraine at the place I just showed you. So we walked into a place that had lots of rocks on the surface, and we were looking around, and I saw a black, shiny, glassy rock. And I looked at it and I said, I think that's a meteorite because it didn't look like any of the other earth rocks that were around. We picked it up in a tongs and we turned it over, and we immediately knew it had black volcanic rock with white bits in it, and it looked exactly like a full moon, which has dark places and light places. And this indeed was a piece of the moon. So that was my favorite space rock or meteorite that I ever found. We found, or well, we as a team, we find the meteorites together. So it was a lunar meteorite, and they're pretty rare. There's only about 300 ever that have been found in history. So that was my favorite one.
Wow. Okay. The next question is from Kate Blevins. Do most meteorites fall in Antarctica?
They don't. In fact, meteorites fall everywhere on Earth with equal chance, kind of random probability. But Antarctica being covered with ice for so long, those millions of years, those meteorites are kind of like land and then are covered up and incorporated into those glaciers, and they actually are like a deep freeze. So they last a long time in Antarctica, and like I said, they can concentrate where that blue ice comes up to the surface, and we can just find them sitting there on the surface. So they don't fall any more than they do anywhere else. But of course, most meteorites on Earth fall into the ocean, and we'll never find them.
Oh, wow. All right. There is another question in the chat. What college did you go to, Mr. Karner?
Yeah. So I went to Bemidji State in Minnesota. That's in northern Minnesota as an undergrad. And I had a professor there that worked at the Johnson Space Center during the Apollo mission days, so in the late 60s and 70s, and he got me interested in planetary science. And from there, I went to graduate school at the University of New Mexico and studied meteorites there. So those are the two universities that I studied at.
Okay. How many meteors do have you found? How
How
many?
many meteors? So when they land on Earth, those rocks from space, we call them meteorites. So they're a meteor when they're coming through our atmosphere, but if they land on the Earth, we call them meteorites. And our teams from ANSMET in 44 seasons, we've found over 23,000 pieces of meteorites. Now, I've been a part of teams where we prior for like 10 years. And we've probably found over 10,000 meteorites. So I've been a part of looking at and recovering and collecting about 10,000 meteorites. It's
Are
yeah,
they,
they're all over the place. So if I took any one of these kids or anybody, they'd be an expert at finding meteorites in just a few days out there in Antarctica.
wow. I have a question.
Sure.
How heavy are they? Do you need a team to lift and move them, or do you just find little rocks like we find on the beach?
Right.
How heavy are they?
Yeah, most meteorites that we find are about golf ball size, so they're pretty small. But meteorites in general have iron metal in them, so they are heavier than your kind of average rock of the same size. The biggest meteorite I've found, or we've found as a team, has probably been about 300 pounds. So there's no way I could have lifted that out in the field. We needed a few people lugging it over, and we put it on a sled and then dragged it back to camp and put it in a big container and got it back to McMurdo Station that way.
Wow. Okay. I have another question from Kate. Why do the meteorites in the pictures look so dark and shaped weird?
Yes, that's a great question. Well, meteorites are often black on the surface because they've been burned coming through our atmosphere. So a thin layer in our atmosphere, that's like a fireball. If you've ever seen a fireball or a video of a fireball, that's the rock coming down through our atmosphere, burning up and forming a black crust, like burnt toast on the outside, just a very thin eggshell crust of melted material that's often black. So that's one of the things we look for when we're looking for meteorites is dark rocks. They're often darker than any terrestrial or earthly rock that we see. And that is called a fusion crust on those dark rocks. And they're usually rounded, very rounded, almost spherical, but rounded on every corner, kind of like no jagged edges, no sharp corners on meteorites.
Okay. Have you ever found any that may have been not as black, but was still a meteorite? Like
Sure, we
really
have.
unfair?
Sometimes there are special types of meteorites, sometimes that um, they form like almost a translucent crust or kind of a crust you can almost see through or kind of pink and greenish. So those are pretty rare, but they're really cool when you find those. In fact, the lunar ones sometimes can have kind of a pinkish greenish crust on them.
Okay. I've got a question. How did it feel to go to Antarctica?
How did it feel? Well, I've been there 13 times, so it's
Wow.
been fun. I really like it. I enjoy it. It's really fun hunting for meteorites. It's something that I really enjoy. Just going down there, it takes a long time to get into the field. All those flights. I didn't even tell you that, it takes us 5 or 6 hours on another airplane trip to get out to our field site. But all in all, to get out to the field, it takes about 3 weeks of traveling and training. So once you finally get out there, it's definitely worth the wait. It's a beautiful place. Just and all it is out there in Antarctica is mountains and ice and snow. There's no wildlife. There's no bugs. There's no plants. There's no trees. There's no grass. So it's a very desolate, solitary place, but very peaceful. There's also very, very little noise. Unless there's a plane flying overhead that's going to the South Pole, it's basically soundless out there.
Okay. So what do y'all pack to eat? And did y'all see any penguins?
Yes, well, penguins, so all the wildlife in Antarctica needs liquid water, so they all hang around the coasts of Antarctica. So when we're at McMurdo Station, if we're lucky, some penguins will be out around the coast of McMurdo Station because it's right on the water. And so sometimes we see a penguin, and sometimes a penguin will wander into town, and while they lose their fur, they molt. They'll just stand there for like 2 weeks in a row. They just stand there and lose all their fur. So that's pretty cool. I love to see penguins. Um, and then whoa, what do we pack to eat? So we pack all our food and we take it out there. Like I said, anything that can remain frozen until you cook it on your little camp stove there. But we get very good seafood from New Zealand, so halibut and shrimp and scallops and salmon, food like that, and then we can have all the beef and chicken and those things we need. One thing about Antarctica is you need a lot of calories to keep yourself warm and kind of fatty foods to keep yourself warm too. So we also get a lot of chocolate bars. In fact, you can have one chocolate bar per day per season. So sometimes you'll take out like 100 chocolate bars just in case. So we eat really good food out there, but the downside is you have to cook it all yourself.
Are there any more questions? Well, there's a few more seconds. I know there's one more question.
Angela says, "What does it feel like to be in a place that is always cold?" Um, well, you get used to the cold a little. It is. When we go there, it's the Antarctic summer, so we're in the southern hemisphere, and you're at the pole, so the Earth is tilted as to you'll have 24 hours of sunlight. Uh, and the temperature, like I said, is around 0 degrees. But in your tent, you have your stove on most of the time to keep you warm, except at night when you have to go to sleep, you have to turn your stove off. But then you have a really good down sleeping bag and you can put as many clothes on as you want and you can fill up your hot water bottle and shove it in your sleeping bag to stay warm. But when you wake up in the morning, that's the worst part because it's about 15 degrees in your tent when you wake up. And that is cold. So you have to get that stove going, get some hot coffee. That is the hard part. After day after day is getting up in the cold, getting all the way dressed, and then getting out and starting your snowmobiles and starting the day. But it's not bad after that.
Okay. Any other questions? Yeah. Do you like being a scientist?
I do. I do. I have I think a lot of scientists and a lot of people in general have a curiosity about how Earth works and how the planets work. And um, my job is really cool because I get to go to Antarctica, but I also get to look for rocks from space, and I think that's a pretty unique thing. But just the curiosity of how the Earth works. How Earth works and how the planets work is a hallmark of a scientist, and I think trying to figure out how it all works is the scientific curiosity is fun.
All right. Well, I think that's all the time we have today. We want to thank you so much for your talk and your presentation. I've
Thank
learned a
you.
lot, and it sounds like the kids were very interested as they had lots of questions.
Yeah, they did. Good. Great.
Is there anything else that you would like to add?
Oh, well, I would say that if you want to be a scientist and are interested in science, just continue to fill your life with like this. And in school, try to take some science courses if they're available. But generally, now, with the internet, all that scientific knowledge is right in your hand, in your phone. And so you can ask questions and answer your own questions by study and inquiry like that. So,
Okay. I have one final question that's popped up.
okay.
Do you study anything else? And what else do you study?
Besides meteorites, yes. Well, I am a geologist by training, so that means I first studied Earth rocks. And Earth rocks are a lot like extraterrestrial rocks, just from another planet. So, for my studies, kind of before I got into meteorites, I studied rocks from the different planets, from Earth, the Moon, Mars, and some asteroids. So some of those were meteorites, but I was kind of comparing them to Earth volcanic rocks. So that's kind of the two areas of my research and study.
Okay. Well, yeah, that's all the time that we have for Dr. Karner. We really, really appreciate your talk. I'm giving you
Yeah.
applauses and hands off to you. We also have another webinar series coming up called Human Explorations, Moon and the Mars study of that January 14th. Make sure you follow us if you receive our newsletter, and if not, I'm going to put the VIRTEX website in the chat. Make sure you click on that. We also put things there, and then through our MailChimp newsletters, we'll be advertising that as well.
Yeah. Who's giving that presentation, Yolanda?
Pascal Lee will be
Oh,
giving that
great.
presentation, and I
In
look forward to that.
Pascal Lee has been on a Antarctic meteorite search. So
Ah,
yeah, I don't know
wow.
him personally, but I know he's been. So that'll be really good.
All right.
Try
Well,
to
thank
tune
you
in.
all so very much. I'm going to stop the recording now, and we're going to end this wonderful and fabulous presentation. Thank you again, Dr. Carter.
Thanks,
Thank you
Yolanda.
all of you for joining today.
Thank you, Boys and Girls Clubs.
Bye-bye.